Hello and welcome to our discussion on crashing of a PERT network. Now in last lecture where we were introducing the concept of crashing, we took this example where we have a network with the relationships 1 to 1, 3 to 4 and so on. We have their normal durations and crash durations, we have their normal costs and crash costs, and then we also found out the cost slope. What is the cost slope? Cost slope is the additional amount that will be paid for 1 day of speeding up of task. If you wish to speed up the task by only 1 day, this is the amount that you'll need to pay. That was cost slope. Then we made this network. Now this network has all the information provided in the table. What is the information? Normal duration is 8 for activity 1 to normal duration is 8, crash duration is 5 and cost slope is 45. This is the information that was given in last example, last lecture where we opened up this example. Now we'll advance on to crash this network. Now we talked about crashing. There can be two possible perspectives of crashing, two possible ways of crashing. One is minimum cost, which is also known as optimum duration, and the other one is minimum duration. So we'll go for these two methods one at a time. And yes, along with this information, some additional information is given which says that indirect cost is equal to ₹50 per day. This is additional information. Now let us try to solve this for optimum duration or minimum cost. Today we are learning minimum cost, or also we can call it optimum This is what we'll be learning today. Either minimum, we can call it minimum cost, or we can call it optimum duration. This is our question. We'll make it double line. Fine. Now this is the network. How do we start? First of all, let me establish what is the critical duration. What is the critical path? What is the critical duration? So what is the critical duration over here? I'll calculate it over here itself. What are the paths? How do we calculate critical duration? We find out all the paths from the first event to the last event. The first event in this network, if you see, is 1, last event is 6. How do we identify first and last events? First event is through which only outgoing activities can be seen, and last event is one where only incoming activities are there. There is no outgoing activity. This you can check in previous videos also. Here we can see that 1 is our opening event, 6 is our closing event. So from 1 to 6, what are the various possible paths? 1 to 6, the paths are 1, 2, 5, 6, 1, 2, 5, 6. Then there is 1, 2, 4, 6, 1, 2, 4, 6. Then we have 1, 3, 4, 6. And finally we have 1, 3, 7, 6. 1, 3, 7, 6. We have 1, 2, 5, 6. 1, 2, 4, 6, 1, 3, 5, 4, 6 and 1, 3, 7, 6. These are the paths from first activity to first event to last event. What are the durations of 1, 2, 5, 6? Right now it is being done normally. So the duration would be 8, not 5, not 7, not 6. It will be 8. 8 and 7, 15 and 6, 21. Right now the duration is 21. 8 and 9, 17, 17 and 7, 24. Then for here we have 6, 18, 25, 6, 18, 50. It will be 6, 12, 19. Then there is 6 and 4, 10, 10 and 6, 16. We have our all the paths, and which one is the critical? 24 is the critical. So what is 1, 2, 4, 6? 1, 2, 1, 2, 4, 6. This is the critical path. Now the idea in minimum cost duration is you check the next critical path. 24 is the critical path. What is the next? If I remove this 24, what remains of next? Next critical would be 21. So right now the critical is 24, but the next possible is 21. So what I'll do is, I'll try to bring this 24 down to 21. Understand very carefully. Right now the critical is 1246, that is 24 days, longest duration. The next possible critical is 21, that is 1256, this 1256. So this becomes my benchmark. Right now I'm at 24, I'll bring it down to next critical, that is 21. In minimum cost duration, this is the idea. At each stage we stop, we check the critical path and we try to crush it to the next critical path. Right now we are at 24, I'll try to crush it to 21. That is the idea. Fine. So right now we are at 1246, we'll try to bring it down at 1256. Now in bringing 1246 to 1256, this is 1246, I need to speed certain activities up. I'll have to provide them with some additional resources so that they can finish their task earlier. How many days do I wish to crash? How many days do I wish to contract? 24 comes down to 21. So I wish to contract the activities by 3 days. This path is being done for 24 days. I wish that this path could be done in 21 days. Is it possible to do it 21 days? 21 days is crashing the network, crashing the path by 3 days. We can crash this activity alone by 3 days. We can crash this activity by 4 days. We can crash this activity by 2 days. So 3 and 4, 7 and 2, 9. This particular path, that is 1246, which is the critical right now, can be crashed by 9 days. I only need 3 days. From these 9 days, I'll be selecting my 3 days. Which will be my 3 days? My 3 days will be such which will cost me least. Which is the activity that costs me least? This costs me 45 rupees per day. Cost slope. This 20, 60. So this is the cheapest. So what I'll say is, I'll declare that crashing 24 by 3 days. You need 3 days because you need to bring 24 down to 21. You need to crash it by 3 days. You can crash 3 days over here, 3 days over here, 2 days over here, anything. But this is the cheapest. Here I'll be making a payment of 45. Here I'll be making a payment of 60. So this looks to be the best proposition. Make only a payment of 20. And where is it? 24. So crashing 24 by 3 days. At what rate? At rate of 20. Crashing 24 by 3 days at rate of 20. What happens? We get a new network. We will have to make new network each time. So we have 1, 2, 3, 4, then there is a 5, 6 and 7. Everything else is same. All we have changed is we have crashed this. So all the information will be 8, 5, 45, 6. You can leave it 6. This was the first figure where we were bringing in all the normal and crash durations. But now I know that there is no possibility of crashing it. There is no cost slope. So I can leave it as 6, 6, 4. Then this will be 6, 4, 30. This will be 7, 5, 60. Then we have a 6, 4, 20. Then there is a 7, 4, 40. This is the activity that I have crashed. It was being done in 9 days, but I have crashed it by 3 days. So now it will be done in 6 days. So I will be doing it in 6 days, but it can be done in 5 days. Right now I was doing in 9 days normal. but it can be done in 5 days. Instead of bringing it down to 5 days, what I am doing is I am bringing it down to only 6 days. So now it is being done in 6 days. Earlier it was being done in 9 days. Now it is being done in 6 days. And what is the cost law? Further, if you try to reduce it, it will cost you 20 rupees per day. So all other activities are same. The only difference is in this activity. Instead of 9-5, it has become 6-5. Now again, can we have our paths 1, 2, 5, 6, 1, 2, 4, 6, 1, 3, 4, 6 and 1, 3, 7, 6. What are their respective durations? 8 and 7, 15 and 6, 21. Then there is 8 and 6, 14 and 7, 21. 6 and 6, 12 and 7, 19. And this is 6 and 4, 10 and 6, 16. So we see that 21, 19, 16, 21, 19, 16, everything is same. The only difference is 24 has come down to 21 because this was the idea. Bring critical path down to next critical. This was critical, bring it down to next critical. That was the idea that we have done. 21 is now down to 21. So now I have these two as critical, 1, 2, 4, 6 and 1, 2, 5, 6. Both are critical. 1, 2. We have two critical paths, 1, 2, 4, 6 and 1, 2, 5, 6. What is the total cost? Total cost would be all this direct cost plus indirect cost. So what is the direct cost? We can add it. Direct cost would be 165 plus 240, 165 plus 240 plus 180 plus 40. It is 625. Let us check. We had a 40. Then we had 180, then we had 240, then we had 165. So it is 625. So the direct cost is 625. I'll remove this name of the method and just put this thing over here. Total cost is direct plus indirect cost. What is the direct cost in this case? We have added these direct payments, 625. What is direct cost? Normal payments that are being made. Right now you are working in 8 days, 9 days and so on. So if you are working in these durations, these are the normal payments that you are making to the teams. If a person is working for you, you are making a payment. So these are the normal durations, so these are the normal payments. These are the direct costs. What is the indirect cost? Indirect cost is 50 per day. 50 per day. And how many days am I engaged for? I am engaged for critical duration. I am engaged for 24 days. So 50 multiplied by 24, making it 625 plus 1200, that is 1825. So total cost for first initially when we were starting was 1825. $1200 plus 625, 1825. So when I started the network, my critical was 1246, my total cost was 1825. Now when I have crashed the network by 3 days, my critical is 21, 21, 1256, 1246. What about my total cost? Total cost to start with was 1825. Fine. Now, let us call it previous total cost. Then add direct cost. Direct cost is the direct payment that you are making for speeding up your actions. 9, 5, 8, 6, 5. So you have made a payment for 3 days. 9 has come down to 6 days. You have crashed activity 2-4 by 3 days at rate of 20. So 3 days at rate of 20 costs me 60 rupees. add direct cost, that is 60 rupees less indirect cost. Indirect cost is the payment being made for critical duration. 24 days payment made for 50 rupees, that is 1200. But now the critical is only 21. So payment should be made for 21 days. Why are you making a payment for 24 days? But the thing is that this 1825 already includes a payment of 50 rupees for 24 days. But now it should have been 50 rupees for 21 days. So what I'll do is I'll reduce this payment. Earlier it was made for 24 days. Now I will be making it for 21 days only. So 3 days are removed. 3 days at rate of 50. Indirect is at rate of 50. So it becomes 150. So what is my total cost? 1825 plus 60 minus 150. So there is a net decrease of, we can say, 90 rupees. So net decrease of 90 rupees results in 1735. Now my total cost is 1735. Now look at the beauty of this crashing network. Earlier this was the network, this 24 was my critical duration, total cost was 1825. Just considering the critical path, I saw that if I crash 24 by 3 days at rate of 20, this 1246 will come down to 21. What this does is, when it comes down to 21, it gives me a huge saving over here. My indirect cost gets reduced. This 1825 had a component of 50 into 24, but now it should be 50 into 25. So what I'm doing is, 50 into 21. So I'm reducing that 3 days. Those 3 days are reduced. These are added, and my new total cost is 1735. This is the idea. This is first iteration, result of first iteration. This was my first iteration. Remember the rule? The rule was, look for your critical and bring it down to next critical. This concludes my first iteration. This concludes my first iteration, where I have a new network. Instead of 9.5, I have a 6.5. My total cost, my criticals. Now the idea is, take them to next critical. Right now critical is 21, take it down to 19. Critical is 21, take it down to 19. This is the network. This is my path. Now let us consider these two paths separately. Then we'll take a decision. Just let us consider them. 8.5, 7.4 and 6.4. 6.5 and 7.5. This is the situation. These two are critical. Now you need to bring this 21 down to 19. You need to bring both these paths to 19. One path is 1, 2, 5, 6. Another path is 1, 2, 4, 6. We need to bring both these down to 19. You can check, these are 21. 8 and 7, 15 and 6, 21. 8 and 6, 14 and 7, 21. So right now both are 21, but I need to bring it down to 19. This I am doing only to explain. You need not make this in your fair solution. Now the idea is, we need to bring them down to 19. How can we bring them down to 19? What are the cost slopes? 45, 40, 20, 20 and 60. You are trying to bring 21 down to 19, that is 2 days. Fine. So one thing is clear, that I need to crash 2 days on each path. I do not need to crash only 2 days, I need to crash 2 days on each path. On 1256 I need to crash 2 days, on 1246 I need to crash 2 days. This is 1256. Where is the best possible solution? Best possible solution is 20. Can I crash 2 days over here? I can definitely crash 2 days. So if I crash 2 days over here, it will become 4, 4. Just an assumption. It becomes 4, 4. So I have 8 and 7, 15, 15 and 4, 19. This is down to 19. But what about this path? 1, 2, 4, 6. This is still stuck at 21. 8 and 6, 14, 14 and 7, 21. This is still stuck at 21. So my critical will be stuck at 21. So even though this comes down to 19, my critical is still stuck at 21. What happens now? I am making a payment over here. What will be the payment of 40 rupees? 6 is down to 4. So I have crashed it by 2 days. 40 rupees payment will be made. But what about the savings? Less indirect cost. There is no less indirect cost. Why? Because critical was 21. If you do this solution, still my critical will be 21 because this activity is still critical. This path is still critical with 21 days. So you need to save 2 days on all paths. Then my project will reduce. Understand this. We have a manager. There is team A, team B and team C. 4 days, 4 days, 4 days. How long is the manager engaged for right now? 4 days. If this team finishes its task in 2 days, is the manager free in 2 days? No, manager is not free in 2 days. Who is manager? Manager is the critical path. Even if you speed A up, manager is still stuck. He is still incurring the expenses of rent, of food. So there is no fun reducing only one path. You need to reduce both paths. Now let us explore how we can reduce both paths. One can be done from here. What about this? The cheapest solution is 45, 60, 20. 20 is the cheapest solution. But there is a catch. There is a problem. What is the problem? That only 1 day can be saved. Here you had 6 to 4. You brought it down 4 to 4. You saved 2 days. Here I can save only 1 day. So that is a catch. That is an issue. How do we counter that? What I'll do is, I'll reduce 1 day over here and see what happens. If I reduce it to 5, 5. What happens? 8 and 5, 13, 13 and 7, 20. This has come down to 21. From 21 it has come down to 19. But what about this? This is only down to 8 and 5, 13, 13 and 7, 20. This is not acceptable. And there is no fun in giving 20 rupees over here. When you are only saving 1 day over here. So what I'll do is, instead of taking it down to 4, I'll make it 5. When you make it 5, it becomes 20. 8 and 7, 15, 15 and 5, 20. Fine. Then here we have 8 and 5, 13, 13 and 7, 20. So from 21 I have got down to 20. One thing has been taken care of. 21 is now down to 20. But the idea was bring 21 down to 19. How do I do that? Let me take a pause. This is acceptable. 6, 4 and bring this down to 5, 5. So what happens with my new network? My new network would be something like this. See, this is our first question. So I am making these many figures and I am explaining it in detail. Otherwise, you can just find out by looking at the network what crashing needs to be done. Right now, I have brought down this 6 to 5, 7, 4, 8, 5, 5, 5, 7, 5, 60, 20, 45, 40 and 20. So I've changed this network. 6 is down to 5, 6 is down to 5. Let me check the paths. 1, 2, 5, 6, 1, 2, 4, 6. Durations are 8 and 7, 15 and 5, 20. 8 and 5, 13 and 7, 20. Correct. But I actually wish to bring it down to 19. 21 should be brought down to 19. Can it be brought down to 19? Do we see any scope? Over here in 1, 2, 5, 6, 3 days. 3 days can be saved over here. 3 days can be saved over here. 1 day can be saved over here. So you can save a total of 7 days on this path. Still I can save 7 days. I only need 1 day. What about the second path? We can save 3 days. Nothing can be saved. I can save 2 days. So 3 into 5 days can be saved over here also. But the idea is the days should be saved on both simultaneously, both the paths simultaneously. How do we decide upon that? Now see, if you have a look at this path, this is common to both. So if you save anything over here on 1, 2, 1, 2, 5, 6 also comes down, 1, 2, 4, 6 also comes down. But you need to make a payment of 45. Whereas in this case, I made a payment of 20 rupees here, I made a payment of 20 rupees here. It cost me only 40 rupees. So that was a better deal. But now at this point, if I see this is common and it costs me 45. Other options are, this is exhausted, this is not an option anymore. You can save 3 days over here, 1 day over here. Of these two, definitely this is better. So I decide, just for a moment, I decide that I'll be saving a day over here. If I save 1 day over here, I'll be making a payment of 20. Cost of is 20. But if you are saving a day on this path, you need to save a day on this path also. This is exhausted, this costs you 60 rupees. So if you bring it down to 65, you'll be making a payment of 60. 60 plus 20, you'll be making a payment of 80 rupees. If you make these adjustments, it becomes 8 and 7, 15, 15 and 4, 19. 8 and 5, 13, 13 and 6, 19. Everything is down to 19, but I have made a payment of 80 rupees. Instead of these 80 rupees, if I take this common area, this will bring both these paths down. 1, 2. So if I make a payment of only 1 day over here, 7, 5, leave this. We are not making a payment of 4, 4 over here. We are not bringing it down to, yes. Rather what I decide is, I'll bring this 8 down to 7. So 1, 2, 5, 6 comes down, 7 and 7, 14 and 5, 19. 7 and 5, 12, 12 and 7, 19. I'm not making this crashing. So everything is down to 19 and I'm only making a payment of 45. So which is better? Making a payment of 20 and 60 over here on different paths. See, I'm giving 20 rupees to this team. I'm giving 60 rupees to this team to speed their task up. Instead, what I could have done is, I could have given the additional resources to a common path. So I'm making a payment only once, but both these paths are getting reduced. Earlier also I had a choice, but earlier this was costing me 45, while separate payments were costing me only 20 plus 20, 40 rupees. That's why I made a payment of 40 rupees. But yes, both days could not be saved here. There was a saving of only 1 day. So what I did, I at least saved 1 day at 40 rupees, 28 plus 20, and I'll save 1 day at 45. Now crashing could get confusing in initial questions. So we'll practice some 2-3 questions of crashing and probably you'll be getting the idea once we practice more of these questions. So what have we decided? That I'll be saving 1 day on this. 6 will be coming down to 5. Also here 6 will be coming down to 5. So what will be my statement? My statement will be crashing 2, 4 by 1 day at rate of 20. Then we will say crashing 5, 6 by 1 day at rate of 20. This is the first step where both these separate paths come down by 1 day. 21 comes down to 20. Then I am picking this path, this activity. What is that? Crashing 1, 2 by 1 day at rate of 45. So here I'll be making a combined payment of 20 and 20, that is a combined payment of 40 for 1 day. Here I'll be making a payment of 45, but it is combined in the sense that 1, 2 is common to 1, 2, 5, 6 also and 1, 2, 4, 6 also. So I'm making a payment once, but saving is happening on both the paths. So this is my new crashing program. And now let us see how the network looks like. One, two, 3, 4, 5, 6 and 7. What have we done? We have touched these. This 6 is down to 5. So 5, 5. No fun in writing 5, 5. This 6 is also down to 5. So it is 5, 4. Cost slope is still 20. This 8 is down to 7. So I have a 7, 5, making it 45. And then we have the same 7, 4. Then we have a 7, 5. Then there is a 6, 4. There is a 6, 6 and 4. These will not be having any cost slopes because they are exhausted. They cannot save further. This is having a cost slope of 60, 30, 40. Is that fine? So I have my complete new figure. If I talk of critical path, what will be the durations? My paths will be 1, 2, 5, 6, 1, 2, 4, 6, 1, 3, 4, 6 and 1, 3, 7, 6. What about the durations? 7 and 7, 14 and 5, 19. 7 and 5, 12 and 7, 19. 6 and 6, 12 and 7, 19. 6 and 4, 10 and 6, 18. So the idea was to bring this 24 down to 21. Then they bring this 21 down to 19. Everything going in sync. What about the total cost? There should be a saving. There definitely should be a saving. Why? Because my indirect cost is 50. Once I made a payment of 40. Next time I made a payment of 45. So either ways I was making a payment less than 50. So what about my total cost? Let me find out my total cost over here. Total cost. What will be my total cost? 1735. For this network it was 1735. Then there is some increment, some additional price is being incurred. What is the additional price? For 2, 4, 1 day at 20. 20 per day for 1 day. 20 per day for 1 day. 45 for 1 day. Plus 45. Then there is some reduction also. Indirect cost is being saved. How is it being saved? Earlier the critical was 24, so I made a payment for 24 days. That is 1200. But when the critical became 21, I subtracted 3 days because I will be making a payment only for 21 days. So I subtracted 3 days from this. 3 multiplied by 50. Now the 21 has come down to 19. So I will be extracting 2 more days. So that will become 2 multiplied by 50. 21 is down to 19. My criticals are down to 19. 21 is down to 19. So I will be making a payment only for 19 days. Earlier it was for 24 days. Then when it became 21 days, I subtracted 3 days. Now it is 19 days, so I will subtract 2 further days. 2 days at rate of 50, that is 100. So what will be my new total cost? 20 and 20, 40 and 45. 85 paid and 100 saved. So there is a net saving of 15. So this 1735 comes down to 1720. This is my total cost. And this complete becomes one section. Whenever you are making a network, you need to address these 3 issues. One is the network with updated timings. Earlier these were normal timings, potential crash timings, total cost and critical. Next iteration, we have a network, you have total cost, updated total cost, updated critical timings. Also these were updated. 9.5 became a 6.5. Next time round, we again have a network. Again updates, 6.5 becomes 5.5, so it becomes 5. 6.4 becomes 5.4 because you crashed it by 1 day, 5.4. And this 8.5 becomes 7.5 because you crashed it again by 1 day. So updated network with updated timings, updated critical paths, updated total cost. Remember, we are talking of minimum cost. So whenever you are talking of minimum cost, you will only crash it to a limit, to an extent where you are saving more. See, here I was saving 150 and I was paying 60 only. 3 days at 20. Here I am saving 100, but I am paying only 85. So there is a net saving of 15. This will be the idea, this will be the check of whether I am saving or not in a deal. So crashing will only be done if you are saving something, because we are talking of minimum cost crashing. Now, what is the scenario now? We have 19. Next critical is 18. We need to bring all these 19s to 18. Who is critical? 1 to 5, 6 is critical. 1, 2, 5, 6 is critical. 1, 2, 4, 6 is critical. 1, 3, 4, 6 is critical. 1, 3, 4, 6. So all these paths have become now critical. 1, 2, 5, 6, 1, 2, 4, 6, 1, 2, 1, 3, 4, 6. The idea is you need to bring all criticals down to next critical. Let us check. Can I save one day on this path? I can save 2 over here, 3 over here, 1 over here. I only need one day. Can I save one day on this? 2 days available here, 2 days available here. Yes, we can save. Now what about this path? I can save nothing over here, I can save nothing over here, I can save 2 days over here. So yes, a saving is possible on all paths. There is a saving potential. 2 and 3, 5 and 1, 6 days on this. 2 and 2, 4 days on this. 6 days, 4 days, 2 days saving is possible. Should I go for that saving? These two paths, this is the common. Internally, if we see, if you try to crash this one as cheapest alternative, then on this path you have 60 to combat with. Yes, on this path 45 is better, but if you are going with 45, why go with this 20? This 45 is as it is common. So for these two paths, 45 looks a good bet. I'll be making a payment of 45, I'll be saving 50. But wait a minute, there is third path also. You need to payment over there, make a payment for that path also. What is this path? This path is 60. So if I make a payment of 60, this path will be reduced, this path will be reduced. In 60 rupees, I'll be bringing two paths down. But what about this path? I need to make a payment of 20 rupees. So 60 will be made for 1246 and 1346. Both are coming down. But what about 1256? I need to make an additional payment of 20. So 60 plus 20. If you make a payment of 80 rupees, you'll save one day. By making a payment of 80 rupees, you are saving one day. You're saving one day. Saving one day means indirect cost of one day. So you're making a payment of 80 rupees while you are saving only 50 rupees. So does this look like a good deal? We are studying the minimum cost method. Or we can call it optimum duration. Optimum duration. So we can say that we have reached a point where this is the minimum cost. If we further try to contract it, if we further try to crash it, if we try to bring 19 to 18, I need to make a payment of 60 so that these two paths come down. And then I need to make a payment of 80 so that the third path also comes down. So that is a total path of total cost of 80 rupees on three paths. 60 will bring these two down, 20 will bring this down. So 80 rupees paid, but saved only 50 rupees for one day. Other alternative could have been you pay 45 rupees, these two paths come down, but what about this? For this you will have to save here. So 45 for these two paths and 60 for this path. That again is a costly proposition, that is 105. This was only 80 rupees, this is 105 rupees combination. So I will not be paying for 60 rupees, nor I will be paying for 45 rupees. And I will be saying that this 720 is my best possible cost, minimum possible cost and optimum possible duration. What is the optimum possible duration? 19. Instead of 24, my team will be free in 19 days. The manager who was engaged for 24 days, now will be engaged for 19 days. So that is the idea of crashing using minimum cost method or optimum duration method. Now can I have my answer? Minimum cost is 1720. Optimum duration is, what is the optimum duration of the project? 19 days. This is where we decide about 19 days from. Optimum duration is 19 days, and this is the optimum path. This is the optimum network. So in two iterations, first the original one, first iteration and second iteration. In two iterations, we have reached a state where no further crashing is possible without increasing the cost. You can crash it further, but it will increase your cost. So we'll stop at this point because we are not ready to increase the cost. We want minimum cost. This is our first method, that is minimum cost method. Right? Next time when we meet, we'll talk about optimum duration method. These two methods are completely optimum duration. Sorry, this was optimum minimum cost or optimum duration. Next time when we meet, we'll talk of minimum duration method. Minimum duration method has completely different ideology. Here the ideology was that take the critical to next critical. 24 was taken to 21, 21 was taken to 19. Now we had a plan to take 19 to 18. So in minimum cost or optimum duration, we take the critical path to next critical. But when we meet next time for minimum duration method, least duration method, that will be a different ball game altogether. So until we meet next time, do take care. Thanks for watching. Bye-bye.